everyone, I am Dr. M. Laxmi Devi, Associate Professor in the Department of CSCDS at Institute of Aeronautical Engineering. In today's video lecture, we will discuss about variables and data types in C. So first, let us see what are variables. So variable, you can say that it is used to store values, or in other words, variable is an identifier. Variable is an identifier used to store values. So variable is a data name used for storing a data value, or you can say that these are containers for storing data values. So associated with variable we have memory location, and it can store single value at a time. Its value can be changed during the program execution. So that is a property of the variable. So its value can be changed during the program execution. So let us illustrate, or let us understand the concept of variable with the help of one simple example. So here is pictorial representation how a particular variable is stored. So here area is the name of the variable. Area is name of the variable name, and in this we have the value 24. So this corresponds to the value in the memory location. So associated with the variable we have memory location also. So this is the address of memory location. So address of the variable is 2000, and its value which is stored here in the variable is 24. Now there are certain rules in order to create a variable, or for naming you can say that for naming a variable we have certain rules to be followed. So it can contain any combination of alphabets, digits or underscores. So it can have alphabets, digits or underscores, but the condition is that the initial character should be an alphabet or an underscore it should be. And then the variable name should not be any C keyword. So we have seen that there are certain set of words which are reserved words called as keywords. So these keywords cannot be used as variable names like int, double, etc. So these are certain keywords. So variable name should not start with a digit. And then the variable names may contain combination of uppercase and lowercase letters. For example, this sum and sum, these both are not same. Then use of commas and blanks are also not permitted within a variable name. Then none of the special symbols. So there are certain symbols. So these special symbols cannot be used in the variable name. So except underscore. So only underscore can be used in the variable name. Next, these are some valid variable names and invalid variable names. So some of the valid variable names are AVG, then underscore followed by PI, then number of students. So you can see that we have used underscore here. So underscore is correct. Next is int. So if you write int here, so int is a keyword. So int is a keyword. So that cannot be used as a variable name. Next is invalid variable name. Invalid variable name is, so int is a keyword here. So therefore this we cannot use as a variable name. Next, double. Double is also a keyword. So therefore this also cannot be used as a variable name. And next here, third entry. So here first character is a digit. So therefore this also cannot be used as a keyword. Next here we have special symbol, so which is not allowed for a variable name. So these are some valid variable names and invalid variable names. Now associated with each variable we have a data type. So each variable has an associated data type. So what value? So in the pictorial representation, so here we have seen that area is variable name, and in that we have the value. So data we have 24. So this is called as, so depending upon this value, so what type of value it will store, that refers to data type. So this depends upon the data type. So when we are using variables, so we have to first declare the variables. So declaration involves specifying the data type of that particular variable. So declaration of a variable gives an introduction of variable to the compiler and its properties like scope, range of values, and memory required for storage. So there are different data types. Depending upon that data types, different amount of memory is required for storing a particular value. So therefore, in the declaration part of the program, we need to specify the data type of the corresponding variable. Then what are the scope, then range of values? Let us see one by one. Scope of variable is nothing but lifetime of a variable. So up to what extent we can access a particular variable, or in other way you can say that it is a block of code under which the variable is applicable or alive. So the certain part of the program where we can access that particular variable is called as scope. So depending upon the scope, we have two types: local variable and global variable. Local variable is declared inside a function and its scope is local to that block or function where they are defined. So default value of local variable is garbage value. So for example, if we write, so this is a user created function. In the declaration part, if you write some int a, so this is a local variable. So this is a local variable, and if you write here outside the function, if you write, so if you declare any variable int b, so this is a global variable. So this is global variable, whereas the variable which we declare inside the function, that is local variable. So this particular variable can be accessed inside this function only. So inside this function only. So we cannot access it outside the function, whereas this particular variable can be accessed inside the function also. So it is declared outside the function. Its scope is global. Default value of global variable is 0. So generally we declare a variable as global so that we can access it for in many of the functions. So default value of global variable is 0. So if you don't assign any value to it, and if you try to print the value of this b here, so you will get 0. Next is coming to data types. So data types are declaration for variables. So it is an attribute that tells a computer how to interpret the value. So type of data that is going to be stored in a variable. So data types, it is classified into 3 types: primary, user defined, and derived. So let us see the first one, primary. Primary data type. So these are the inbuilt data types, you can say. So these are primary data types are those which are defined in programming languages. So these are predefined and also they are known as inbuilt data types. So these data types are the basic building blocks of any programming language. So we can classify primary data types into 4 mainly. So this classification may vary in some of the textbooks, but here I have given primary data types is classified into integer type. Next we have floating point type, the character type, and void data type. So let us discuss each one in detail. First one, integer data type. So in order to declare a variable as integer data type, so we need the keyword used is int. The keyword used is int here. So it is used to store only integer values. So int data type will hold only integer values. So integers are again classified into 3 classes of storage with both signed and unsigned qualifier. So you can see here int is again classified into 3 classes of storage: short, int, and long. Again this short int is classified into 2 based on the qualifier. So you can say that these are the qualifiers: signed, unsigned. So int again you have signed and unsigned. Long also you have signed and unsigned. So depending upon whether it is a short signed int or whether it is unsigned short int or signed short int, so memory requirement may be varying. So for example, for storing a short data type, so unsigned short int, unsigned short int, if you write this here, so if you declare a variable in this way, so then it requires 2 bytes of memory. So, or if you write short int a, this one also requires 2 bytes of memory, as you can see here. Sure. But if you don't mention the qualifier here, so then that signifies signed. So by default, that is a signed. Signed shortened here. A. Now for integer, the memory requirement can be 2 bytes or 4 bytes. So that depends upon the machine or the architecture of the computer. If it is the machine can be 32-bit or 64-bit or 16-bit machine. So depending upon that, the integer data type can occupy, or it requires 2 bytes or 4 bytes of memory. Next to long int, long signed int and unsigned long int. So for this we require 4 bytes. So this, how much memory is required, that depends upon the architecture of the machine, as you can see. And then there is an operator called as size of operator. So you can determine how much memory is required for a particular data type by using the size of operator. So if you write size of int, so print, I'll write here. So by using size of operator, you can actually determine how much memory is required for a particular data type. So for example, if you write printf, then this is a format specifier. This is a format specifier. Size of int. So this statement will give the size of integer data type. So in this way, you can determine the size of other data types also, like float. There are other data types like floating point, then character, and etc. So for that also you can do the same. So using the same statement, so just instead of using int here, so you can use corresponding data type, corresponding float. So in order to %d printf. So this will give the size of float data type. So format specifiers. So what are format specifiers? So here in this table, all these are format specifiers. So what are format specifiers? These tell the compiler about the type of data that must be given or input and the type of data that must be printed on the screen. So what type of data we need to the computer has to print. So that is determined by these format specifiers. Suppose if we want to print integer value, then the format specifier is %d. If we want to print the short int, then the format specifier is %hd. So, and then the corresponding for this, the memory required is 2 bytes, and for integer the memory required is 2 or 4 bytes. This depends upon the architecture of the machine or the bit size. And then these are the range of values. So this, in this table you can see in the first column we have the data type, second column the size, that is the memory required by that particular data type, and these are the range of values, and in the fourth column we have the format specifier. So for example, so short int, it requires 2 bytes of memory and range of values for so here we did not mention the qualifier, that is whether it is signed or unsigned. So if it is not mentioned that it is signed or unsigned, by default it means it is a signed. So implicitly it implies signed short int. So range of values are, so these values can be calculated by the formula. So we have the formula minus 2 power n minus 1 to 2 power n minus 1 minus 1. So for example, this is for signed. If the corresponding data type has signed qualifier, then this is how we calculate the range of values. So this corresponds to minus 2 power. Here n represents the number of bits. So 2 bytes, this is the size given in 2 bytes. So 2 bytes corresponds to 1 byte is equal to 8 bits. So 2 bytes is 16 bits. So we can write here 16 minus 1, 15 to 2 power 15 minus 1. So in this way, we can, this value corresponds to this one, that is minus 32,768 to 32,767. So if it is, then if we don't have, if it is an unsigned, if the qualifier is unsigned, then for unsigned short int, the formula is 0 to 2 power, range of values are 0 to 2 power n minus 1. So that means 0 to 2 power n is 16, 16 minus 1, 15. So this corresponds to 0 to 65,535. So in this way, we can calculate the range of values. So this is an example. This is how we can calculate the range of values for a particular data type. So if we have the qualifier signed, then the formula is minus 2 power n minus 1 to 2 power n minus 1 minus 1. And then if it is unsigned, so 0 to 2 power n minus 1. So where here n corresponds to the bits, the number of bits you can say. This is number of bits. So character data type, so that we'll see later on in the next slides. Character data type, suppose it takes 1 bytes of memory, then we can calculate the range of values by, we know that 1 byte is equal to 8 bits. So therefore making use of this formula, so minus 2 power 8 minus 1 to 2 power 8 minus 1 minus 1. So therefore it is equal to minus 128 to plus 127. So in this way we can calculate the range of values for a particular data type. Next is floating point type. So in floating point type, so we use the keyword float in order to store floating point data types, or in order to declare a variable as float data type, then the keyword is float, and then double, then long double. So these are the keywords which we use. Float and then variable name. Suppose A we write, so then this variable belongs to float data type. So this is the table. Here also there are 4 columns. First column represents the data type. Second column represents the memory location. Third column is range of values or range limit. And the last column is format specifier. So float requires 4 bytes. And then the range of values you can see here, 1.2 10 power minus 38 to 3.4 10 power plus 38. So these values also you can calculate by using the same formula which we have discussed in the previous slides. So format specifier to print a float value is %f. Suppose we are writing a is equal to some 4.2. So this is a floating point number. So we need to declare also. So this is the declaration part. So here itself we have assigned the value of float also. So in order to print the value, so on the screen we use %f and then a. So this is the format specifier in order to print a floating point data type, floating point variable. Next is double. Size is 8 bytes. 8 bytes. These are the range of values, and the format specifier is %lf, small l, small f. Then long double, the size is 12 bytes. Range of values is 3.4 into 10 power minus 49302 1.1 e 10 power 4932, and the format specifier is %lf. Here L is capital LF. So what is the difference between float double and long double? All of them are used to represent or used to store real numbers. So but the precision varies. So in floating point, the number can be represented accurately up to 6 decimal points. It has 6 decimal precision point, whereas this double has, we can represent up to 14 decimals, and long double data type can be represented up to 19 decimal places. So that is what the difference between float double and long double is. Next is character data type. So single character, so anything which is there in single quotes, suppose 1, this is also a character data type, this is also a character data type. So a single character in C is of character data type. Then characters are stored in, so character data type requires 1 byte of memory, and the character can be signed and unsigned. So there is no dedicated character type in C. So character is same as integer type. It is just a smallest integer type. So what is this? We'll see. So like any other integer, it can be signed or unsigned. So in C, characters are stored as the ASCII value of, suppose this we write, suppose char ch is equal to a. So here ch is a variable which stores character data type and the value assigned to ch is capital A. Now this is stored in the memory in the form of it is converted to integer with the help of its, so its ASCII value is 65, sorry. So ASCII value of A is 65 and this value is stored in the memory. So signed and unsigned character both used to store single character as per their ASCII values. So next, small a. The corresponding ASCII representation of small a is 97. So a is stored as 97. So signed character name a is equal to this and this, both are same. If you don't mention any qualifier here, then by default it means signed. Next, these are the character data type. You can include lowercase letters, lowercase alphabets from A to Z. So from A to Z it has, so it starts with 97. So in computer A is stored as 97, its ASCII representation is 97 and then it goes on 97, 98, 99, 100 and so on. So all these are character set in C. Next, it can contain uppercase alphabets from capital A to capital Z. Then it can contain digits from 0 to 9. It can contain special characters like all these are special characters in C. Then it can contain white spaces also and then new line. So white spaces means these are the carriage return, then tab, etc. All these are white spaces. So all these represent character data set in C. Next one is void data type. So what is void data type? Actually, we don't have any void data type, but it is used mainly with functions. So it is used to mainly specify the return type of the function. So function with no return value and no arguments. So that is called as void. So we cannot we cannot declare a variable as void. So void A. So normal variable cannot be declared as void directly, whereas a pointer can be void. So for example, so function with no return value and no arguments. So for example, void function. So this is a return type of the function and this one is the argument. So the function which has no return value and no argument. So there we use void type. Next is user defined data types. So user defined data types, these are derived from the existing data types, or in other way you can say that these are customized data type. So advantage of using user defined data types is that it increases the program readability. So program readability enhances. So the three main types of user defined data types are enumeration type, next one is structure type, then last one is union. So let us see first one, enumeration type. So enum is the keyword. Enum is the keyword with which user defined data type is used to declare the variables within the curly braces. So syntax for this is enum and then the name of this enum. This is a flag nothing but the name of the name, or you can say that this is the identifier of the enum, and then inside this you can have constant name 1 separated by commas, constant name 2 and so on, etc. So here enum is the keyword. So in order to declare enumerated data type or enumeration data type, we have to use the keyword enum. This is written at the beginning of the definition. Next to flag is the identifier, you can say, or name given to the default name of the enumeration set. So it can be replaced by another name or can be used as it is. Next, constant name is here inside this we have constant name 1, 2 and so on. So it is integral identifier inside the enum set. So if you don't assign any values to these constants, so by default the compiler will assign or default values of this set are 0, 1, 2, and so on, depending upon the number of constants we have given here. So one example is here. Enum is a keyword with which the user defined data type is used to declare the variables within the curly braces. So starting is enum, after that this is the identifier, then inside the curly braces we have 3 variables, or you can say 3 constants: Monday, Tuesday and Wednesday. So and then after that, so int main function, here we are declaring the variable for this enum week. So for this enum week we are declaring a variable, and to that variable we are assigning the value Monday. So here we are assigning this Monday constant. Monday is here no value is assigned to this, so by default it indicates 0. So if you want to assign any other value to Monday, then we have to implicitly give the value here. We have to explicitly give the value here. Suppose Monday is equal to 1, Tuesday is equal to 2, this is equal to 3. Now with this statement, so its value will be printed as 1 now. So this is the variable, and this one is the identifier. Next is structure. So structure is also a user defined data type, which allows us to group together data of different types together. So keyword struct is used, followed by structure tag to define the structure. We'll see the syntax. Then we have the closing brackets in the structure type declaration must be followed by a semicolon. Then size of the structure is same, would be the sum of the storage size required by every variable. So in structure we have, so this is the syntax to declare a structure. Struct is the keyword name, then after that curly braces, starting of curly braces, and then data type, and then variable 1, and then again another data type, variable 2, and so on. So here itself we can declare the variable for this structure, or in the function also you can declare a variable for this structure. For example, this is struct name, suppose D1. So here D1 is a variable created for the structure name. So let us see the syntax here. So syntax is, first we have the keyword, then structure name, then curly braces inside this. So here these are called as members of the structure. So members of the structure, variable 1 and variable 2. Then at the end we have a semicolon. So here data type represents the variable can have different data type, and then variables can have data types of here variables of any data type can be declared inside a structure. The definition of the structure ends with a semicolon at the end. So that is what given here. Then in order to declare a variable for this structure, so this is the syntax: struct structure name, then B1. So here B1 is a variable for this structure name. Then union. Union is also user defined data type. It holds members of different data types together. So it is also a collection of data types. It is also a collection of variables belonging to different data types. But the difference between structure and union is structure allocates memory to the in structure, the memory allocation is based upon the number of variables, but here the memory allocation is based upon the largest data type or the largest variable, you can say. A structure allocates sufficient memory for all its members. So in structure, the memory location is equal to the sum of memory. Memory location is, suppose we have in a structure, if we have 2 variables, integer n, and another one is float b. So suppose integer requires 4 bytes, and suppose float also requires 4 bytes. So when you create a variable for this, 8 bytes of memory will be reserved for the structure variable, whereas for a union, it will allocate memory equal to the largest member. So out of these two, which one is the largest? So correspond for that, where the union will allocate the memory. Actually, we use unions in order to save the memory. So for saving the memory, we use unions. So Next is union. Syntax for union is same as structure only. So union, but the keyword here is union. After that, the name of the union. Then inside the curly braces, we have the members of the different data type. Your data type variable 1. So this is the data type and this is the name of the variable. So after the keyword union, name of the union is specified and data type is data type of the member variable of the union. Members of different data types can be defined inside a union. The next one is derived data types. So these are derived from primitive data types. So these are called as derived data types. Derived data types are used to add some functionality to the basic data types as per program requirement. So these are also found by grouping of one or more primary types. So these have extended the scope of C language. So in derived data types, we have pointers, arrays, and functions. So first one, pointers. Pointer is a powerful feature that C language supports. So it provides the user to access memory and address of variables, functions, etc. So a pointer, you can say that it is a variable or it can be defined as a variable which stores the address of other variable. If A is storing the address of B, then we can say that A is pointing to B. So data type of a pointer must be same as the variable whose address it is storing. Suppose we have int star P and we have another variable int A. Now, so we can say that this is a pointer variable. So declaration, we can say that this is a pointer variable because data type of, so in order to represent a pointer variable, so we have asterisk symbol. So this is a pointer variable. So if we write P is equal to this, then we can say that P is a pointer which stores the address of another variable. So data type of this and this one should be the same. So whatever the value it is holding, this one, so this pointer should also be declared as with the same data type, integer. So now you can say that P is pointing to A or P holds the address of A. So A is normal variable whereas P is a special variable which stores the address of another variable. So syntax is type or you can say data type, then star, pointer name, semicolon. So type indicates the data type. So that indicates the type of value to which the pointer is pointing. Then pointer name is name of the pointer. So in order to name a pointer, same rules are followed. So as we follow for variables in C. Apart from these rules, a pointer must always be preceded by an asterisk. So that is the difference between normal variable and pointer variable. Then arrays. The second one in derived data types is arrays. So array is also a collection of data. But here data types, these data they belong to the same type. So this data they belong to the same type, or you can say it is finite ordered collection of homogeneous data. These are stored in continuous memory locations. So these are also referred to as structured data types. So it can be defined as collection of variables of the same type. So array is defined using square brackets which defines the array size. So an array can be one-dimensional, two-dimensional or multi-dimensional. So let us see the syntax. So here data type refers to the data type that specifies the type of elements to be stored in the array. Then array name is the name of the array. Size gives the number of elements in the array. If the size is 5, then it will store 5 elements in the, so there will be 5 elements in the array belonging to, suppose if we write int a of 5. So that means, so there are 5 elements corresponding to integer data type. So or in other way you can write int a of 5 is equal to 1, 2, 3, 4 and 5. So here we have initialized the value also. The first element index is 0, second element index is 1, third element index is 2, 3 and 4. So if there are 5 elements in an array, so corresponding indices are from 0 to n minus 1. So these are the positions of the n elements present in the array. So next one is functions. So what is a function? Function is, you can say that it is a block of code which is written to perform some specific task. when invoked in the program. So syntax for this is return type, then function name, and then inside this parameters we have followed by semicolon. So return type gives the type of value to be returned by the function. Function name is the name of the function, and parameters are optional. That depends upon the function. Example of one function we can write. So for example, so void, if you write printf, so this is function definition. In order to use this function definition, we have to call this function. So inside the function we can call this is return 0. So here we are calling the function. So here in the function, in the main function, we are calling this function, and whenever the program will come to this step, automatically the control will be transferred here where the function definition is there, and whatever the statements are there inside the function definition, those statements will be executed. So how many number of, if you run this program, you will get the output as hello. So if you write one more again, if you call the function, so here this hello will be printed 2 times. So in this way, here return type is, so this is the function definition. So return type of this function definition is void. That means it is not returning any function, that means it is not returning any value to the main function, to the calling function. Then this is the function name, and then parameters. Parameters are optional, so we have not used any parameters here. So in this video lecture, we have discussed about variables and the different types of data in C. So in the coming video lectures, we will discuss some more topics about C language. Until then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.